And then like she was talking to him about like financial assistance benefits, and I was like, hey, can you mute your mic? We don't need to hear about this.
Right. That seems like personal info.
Right.
Yes.
We don't need that.
Oh boy. Well, I want us to just check in real quick about the schedule. That just seems like a good time for us to do that. So let me share my screen here. Okay. So here we are. It is week 7 of class. Lab 2 is due today. This says before class. If you turn it in by midnight, that's really all I care about. So feel free to take in some extra time. Today, we're going to be talking about sampling and sampling distribution. And next week, which is week 8, is the exam. So as I said, I'm going to make the exam available to all of you guys probably earlier in the day. I'm going to say probably around 10 or so. I'll make it visible. And then you go ahead and take it and submit it. Now, the exam is going to have 2 parts. There's one part that's going to be, follow along, answer questions. Some of them are a bit more conceptual, theoretical. And I'm just realizing now I'm recording my screen and I'm wondering which
But you
screen
said
is.
it opens up at 10 or 10 a.m. on Wednesday, correct?
Yes.
Okay.
Yes. So opens up at 10. One section is going to be more conceptual questions and some calculation, but that would be done by hand. Some of them might be like create a frequency table. So again, you can insert a table within text, or you can actually draw it out, take a photo. That's totally fine. And then there's going to be a separate section that'll say exam 1 Excel. And those are Excel analysis that you need to do that are very similar to the labs that we have done thus far. And then you will need to save your Excel document, or if you're using Sheets or whatever thing you're using, and then answer the questions that way so that I know how you got the answer. So it is a 2-parter. Again, when I was hosting both of those, like the exam with both those parts in a regular class setting, most people were done with an hour, maybe an hour and a half. So it should not take you that long. If there's something you're really struggling with and you're like, this is not making any sense, like, I don't know what she's expecting out of me. This is not something we've learned. Please do contact me. Let me know. I'm happy to help. You will notice also on there, I will have a Z-score table, just like we covered last week. That is one table you may use. You may Google Z-score table somewhere else and use that if you find another one, or use the one from your textbook. I'm not married to either idea. So, yeah. Any questions about the exam?
So this might be a dumb question.
It's not, I'm sure, at all. Go ahead, Hannah.
On the day of the exam, do we have to show up to class if we like take it earlier the day?
Not a dumb question at all, And it's a very important question. No, there is no class. So if you take the exam at 10, great. If you decide I'm a night owl, I would like to work under pressure and I want to start this thing at 11 at night, you do you. Totally fine. We are not having class. I have done it in the past, like especially if we're having in-person class where we take the exam and then have a little break and then do lecture. I just find that doesn't work all that well because people will take the exam at different pace. And then, it feels awkward if you're the last one there. You feel this like social pressure to hurry. I don't like that. So the exam is all we've got next week. Does that help? Okay, good. Any other questions? Okay, so again, there should be no surprises on the exam. Really, if you look at the syllabus, everything we have covered thus far will be included on the exam in some fashion or another. So, when you look, again, measures of central tendency, make sure that you know how to calculate a mean, median, and mode, right? That's going to be on there. Know how to organize data with a frequency table and possibly even graphing something like a pie chart or a histogram. Know about the normal distribution. And we talked about, again, when you're looking at a normal distribution, what percentage of people fall in each band, right? So within 1 standard deviation, 2 standard deviation, what does that look like? Know what variance means. What is it? How do we calculate variance? What's different with the standard deviation? How do you calculate a standard deviation period? I mean, we've done that through Excel calculations and all of that. Make sure you look that over, and then make sure you know about a z-score, how to compute a z-score from, like we said, like when we were doing that last week, how to look inside the chart and figuring out what percentage of people, what's the percentile, and how many people did they beat out, like out of 100. Again, you get that percentile number. Okay, questions about that, or are we good? Okay, good. All right, so now let's go. I don't get Zoom, gang. Like, I have this thing open, but somehow it's not open enough. It doesn't show it on the shared screen. Here it is. Okie dokie. All right, everybody can see this? Okay. All right, so we are going to be talking about sampling and sampling distribution today. This is chapter 6 of your text. So some of the goals we have for today are going to be describing the aims of sampling and basic principles of probability. This is one of my favorite things. Because many people are like, you can't really see me, but I'm like, anyway, I wish this was, you know what I mean? I'm crossing my arms. I'm never going to use statistics again. Statistics is silly. And I'm like, will you though? You will, because laws of probabilities will stick with you forever. From the moment that you're like, should I buy a lotto ticket? It's worth, what was the lotto recently? It was like some absurd number, like 900 million. Am I remembering? Like a couple months ago, it was some absurd number. People are like, oh, I should totally buy the lottery because, you know, I could win. Somebody's got to win. I could win. Laws of probability would probably teach you the benefit of keeping that $2 in your pocket rather than donating it, right? We'll also talk about the relationship between a sample and a population. We're talking about different sampling designs that can be used when you're doing research. And then what is an actual sampling distribution and how does that relate to the central limit theorem, specifically when we're looking at z-scores. So those are the goals for this evening. So why do we sample, right? The word sample implies what? When you guys hear sample, subset, what are you thinking then?
Only part of the whole group.
Part of the whole group, okay. So question for you guys, why would we ever want to do a sample? Why not just look at the whole group all the time?
Sometimes the whole group is too large and it would
Okay.
take too much time.
Okay. So I'm hearing efficiency-wise, it's a little better to do it that way. I think somebody responded in chat. Not accurate enough. Is a sample, Hasher, I want to make sure I'm understanding. Narrowing it down to make it less vague. So if you do a sample, it's more accurate than a population is what you're suggesting? Am I hearing you correctly? I can't.
Yeah, so like I feel like if you were trying to like I don't know, like I guess like what's the word? Kind of like focus, like kind of like put emphasis on like a certain group. Like it would be easier if you like take a sample from a certain, like a bigger population, because I feel like you could more closely monitor it. And then like, I don't know, maybe I'm wrong.
No, you're on the right path. Again, you're talking about efficiency, right? Like if you're going to be monitoring a behavior over time, it's much simpler and easier to do if it's a smaller group than an entire population. Absolutely. Yeah. I think those are the crux of it, gang. Like a population is ideal. If I was able to look at the entire population of the US, I would probably glean some really helpful information. But the truth of it is, how often do we do a census in the United States? Do you guys know?
Every 10 years.
Every 10 years. And there is a reason for that, because it is costly, it is time consuming. In the end, do you get 100% data? No, there are still people who are not, that's why they send people to knock on doors and be like, we want to make sure that you're counted. Like they're really trying to get every single person. But to attain that is very hard. So a population is a group that includes every single case that the researcher is interested in. It could be individuals, objects, groups. So for instance, I listed some right here. All of Aquinas would be 2001 students. Now, I think this was like, I made this 2 years ago, so it might be a little off now, but all students would be a certain number. All people who live in Grand Rapids, the population of Grand Rapids, population of Michigan, Canada, America, women on earth, right? Like those are the entire population. Now, if I'm trying to do a study on women's perception of gender equality in work environments, do I want to be polling and asking and interviewing possibly all women on the face of the earth? No, that doesn't make sense, right? So you then take a sample, which is a relatively smaller subset from the population. Now, when you're doing that, though, you want that subset to generalize to the entire population. So with my example, I'm interested in American women's view on gender equality in the workforce in regards to income. And then I ask, and I'm just going to pick people at random here, the people I see. So Diana, Hannah, Grace, Stephanie, and Cami. I ask all of you to tell me your views on it. Do you feel like there's actually like income equality, right? And then you would give me the answer, whatever you think. Yes, no, maybe so, whatever. And then I said, based on a study, American women feel that there is gender equality for income. Is there a problem with that?
The sample's really small and it's only from our class. Like it doesn't have like a variety of, I don't know if that makes sense.
No, you're spot on. So first off, my sample is very small. If my entire population is, what is that number? That's 3 billion. Gosh, I'm embarrassed now. I think it's 3.7 billion, right? That's a lot of people. And if I'm like, to represent all women, I feel like I only need 4. 4 people should represent the entire population of women all across the world. Well, no, that doesn't work. And then the fact that you guys are all in the same class, probably relatively close in age, maybe even same racial and ethnic group, I've now homogenized my sample in a way that is no longer representative of the population. So that is not a good sample, okay? The same way that if I asked our class, how many people are in class right now? There's 11 plus me, 12. If I ask the 11 of you to give me your opinion on, let's do something yes or no. Oh, yes or no. Do you like the Aquinas mascot? So if you, let me do this so I can count it because we're going to make this, we'll make, whoop, not highlighter, so sorry, pen. Okay, so yes, you like the mascot or no. So raise your hand or type yes in the chat if you like the mascot for Aquinas. Okay, I'm seeing 1, 2, 3, 4, 5, 6. Oh, okay, what? I'm gonna start from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9 with Diana. Anybody else raise their hand that I can't see? 10 with Aaron. Okay. So here, 10 people. Now raise your hand or type in no if you don't like the mascot. Provided everyone is attending class. Anybody saying no? I just am not seeing them. Am I missing something here? Did I miscount? And 11 maybe. Okay, we're gonna go with it. We've got some maybe non-participants. I don't want to miss anybody. Did someone say no and I just missed it? I am not invested in this question. If you hate, it's a bulldog, right? I'm not even sure what it is. Is it a bulldog? It
It's
is.
a Saint Bernard. Yeah.
It's a Saint Bernard. Don't tell the dean. It's a Saint Bernard. Sorry, Liz. Okay. So now if I said 100% of Aquinas students love the Saint Bernard Saint. No, is there a name? What's the name?
It's just a Saint Bernard.
I think his name is Nelson.
Nelson. Okay. Thank you guys. This is why do I pick things I know nothing about? That I feel like I should know better. All right. So 100% of Aquinas love the Saint Bernard Nelson, right? What do we think about that claim and the sample that I use, and does it generalize? What do we think about all that?
I so like taking into kind of like applying what I've learned in like different classes, like I guess I would say like sample size maybe isn't large enough because of like the sample. I mean, like the total population, like looking at like the sample, it's only 10 people, whereas like the total population is, you know, however many, whatever, thousand. And so I guess like you could assume like a majority would, you know, approve of the mascot, but I don't think that the assumption or generalization that everyone would like it would necessarily be like completely accurate.
Totally.
What we came to conclude with these
So-
votes.
You made excellent points. So one is, does our sample is pretty small, right? So if I'm saying there's about 2,000 students total for the population of Aquinas, and I ask 10 people, well, does 10 people actually represent 2,000? That's kind of a small sample size. Second, if I'm not mistaken, their gender disparity in this class is pretty significant, right? We have 2 in the male contingency, 8 or more in the female contingency. Those numbers do not match the Aquinas population gender breakdown. So we don't have a representative sample that way. Next, I would venture to say most of you are probably sophomores. No, junior. Okay, let's do another count. I'm
Freshman.
not sure.
Freshman.
Sophomore. Oh, so am I totally wrong? Senior. Okay. Raise your hand. Well, just type in there what you are. Okay. Oh, so I'm very off. See, this is why you don't assume. All right, let me type in here. So sophomore, senior, senior, sophomore, senior, senior. Freshman, freshman, sophomore. Freshman, junior, freshman. And then one more freshman. 5, 7, 8, 10. Wow, see, this is why I love these classes, because it's fun. I'm like, all of you are probably right here. I am very off. Okay, so this is not an even distribution of grade level, right? We're a little heavily skewed on the freshman end, but there's more, diversity than I thought. If we were looking at the population of Aquinas, though, we have some underrepresentation of other grades rather than freshmen. So again, this would not be a very good sample that I would feel is externally valid to the population, which is all Aquinas students. The sample is too small. We just don't have enough information for it. Bless you. Okay. So why ultimately do we use samples? We touched on that already. But the main reason why we will create a subset of the population is for efficiency, it's for cost, and it's also the laws of diminishing returns. Ultimately, the larger your sample, the greater kind of trust you can have in the data you'll get from it. But you reach a point where there is diminishing return. You will get really interesting and significant data with 1,000 participants, and maybe incrementally you would get more at 5,000. but that would not justify the time and cost and effort that would go into obtaining an additional 4,000 participants. Do you know what I mean? So there are laws of diminishing returns. So capturing the entire population may not get me more information than having a really strong sample where I thought about randomizing and really giving everyone the opportunity to join through some sort of standardized selection and sampling. Okay. So again, I just said that. We rarely have enough time or money to collect data from all the people in a given sample or a given population. So then you take samples from them in order to really grapple with the information that the entire population is giving you. Okay, so you can see here, this is the population right here. This is all Canadian women. And this is a sample of scores of 50 Canadian women that were studied. Notice that the pattern is very similar, okay? Now, if I had, let's say, only 10 students or 10 women that I was scoring, maybe it would look something like this, you know, like it's more susceptible to outliers. But 50 in this case was big enough that it mimicked a normal curve. Same thing here. This is the population of voting preferences for the entire voting age of the US population. So here you see, again, very much a normal curve because we're looking at a very large data set. But this is 1,000 vote, and notice how it mimics it completely. So this is the law, again, of diminishing return. I could go after the entire population, but the amount of cost, time involved in getting that does not benefit me enough in terms of the results that I'll get. So might as well do a sample then. That works quite well. All right, so let's talk about these terms. When you are dealing with a population, any measure that you have, like a mean or standard deviation, the nomenclature or terminology used is a parameter. So parameters have to do with population, which is easy because it's P and P. Any sort of measure for a sample is called a statistic. Again, simple because statistic and sample start with the same letter. All right, so that's the nomenclature you would use. This is the notation. Now, I want you guys to note in your textbook, the mean is often reported as X bar. That's the same thing. X bar, Y bar, that's when you're looking at a sample mean. And then for the standard deviation, yeah, that's a italicized S and variance. Okay, don't worry so much about proportion. We're not going to cover a whole lot of that in this class. Okay, so if I am taking, for instance, this is the parameter. This is the proportion of white respondents in the population. And you can see here my proportion is 0.6. I then take a sample of that population. Here it is. And the statistic becomes 0.67. Notice these two numbers are actually quite similar. That tells me my sample did a good job. It was well sampled because it approximated the proportion, the population quite well. Okay. We utilize probability sampling quite often. And again, the goal is for our sample to mimic the population. That's ultimately the goal. We want to be as accurate with that as possible. So since we cannot test everyone, we estimate the population parameters based on our sample statistic. So we are able to say claims like, and I just talked about this in one of my other classes, 8 out of 10 American drivers have signs of road rage. So I can take the results from my smaller sample and expand it to the entire population by stating a comment like that, 8 out of 10 Americans, right? So I'm grouping all Americans, and I gathered that frequency claim based on a sample. But if I feel solid about my sampling technique, that the sample in fact does reflect the population quite well, then I can make a claim that generalizes to the entire population, which ultimately is the goal, right? Because no one is interested in doing a study that says, At the University of Kansas in 2012, we found that personality traits were such and such. Like, no researcher is thinking like, that's when I will have made it, when I can write a research paper that talks only about my sample. No one cares about that. You want to have research that'll be meaningful to every reader and multiple audiences. So you want it to generalize to the population at large. So once you're using a probability, I just want us to refresh ourselves a little bit. It's a quantitative measure about the likelihood of an event to occur. Okay, we do this all the time. Last week with my children, they said, Mom, are we gonna have a snow day tomorrow? Right? What are we doing? How do I answer that question? What do you guys think?
Percentage for a snow day tomorrow. I feel like it would be abnormally low now.
Yes, you're absolutely right, Aaron. They would be delusional if they thought that'd be a snow day
Dude, I'm on.
No, this was last week. So last week when it was cold and it looked like winter outside, not today, my kids at dinner were like, we're going to do all our tricks, you guys. We're going to put an ice cube down the toilet and put a spoon under our bed and tape a penny to the door. Anybody else do these things to like call us? Maybe just my children, but I'm kind of worried now. None of you guys have heard about any of these superstitions?
I did when I was a kid.
Thank you,
I put the
Camilla.
ice cube down the toilet and the spoon under my bed. So I know, yeah.
Okay, all right. I was like, maybe they're just they've turned weird. Okay, thank you for that moment of reality. But as a parent, I can go and use my handy dandy phone and look at the weather report and look at the probability of snowfall for the next day. So absolutely, right? So I use probability. Weather is a huge one for probability. The probability of precipitation is blah, blah, blah. Or the probability that a hurricane will come in is la, 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 right? Anytime you are predicting a behavior, it's looking at the likelihood of an event occurring. So again, these are some interesting ones. What's the likelihood of getting bitten by a shark? Right? People are very frightened to go swim in the ocean when really the odds are much, much more scarce. Like the likelihood of that happening is very, very rare compared to being bitten by a dog or being bitten by your own child, which all 4 of my children have bitten me at one point or another, right? But does that make me afraid of them? No, right? But being afraid of a shark may be a more reasonable fear. So these are called probability. So what is the likelihood of an event? Okay. When you use probability sampling, you're utilizing kind of the same idea. It's a method of sampling that allows the researcher to specify the case or the person that they're looking for within a population and the probability that they'll be included in the sample. This makes it so that the sample is representative of the population. Okay. So that is what we use. So let me make it a little bit more clear with some examples here. Examples in our couple slides. Let's do a little bit more just background. When you're doing empirical research, meaning you are gathering data, you're reporting on that data, and you're presenting it then to peer-reviewed, researchers, like similar peers in research, that is empirical study, and that is fully probabilistic. Again, the probability is the expected relative frequency of a particular outcome. The outcome is the actual result of an experiment. So the probability is the actual outcome divided by all possible outcomes. Okay, this sounds very confusing. Let's bring it in with an example. Hasher, if I am rolling a 6-sided dice, what are the possibility when I roll it? How many options are there? 6. Very good. Okay. Everybody get that? If I roll a dice, what are my the possible outcomes? Like what is it? It's 6 because there's 6 sides to the dice. Now, if I say, what is the probability that I'm going to roll a 1? What I would do is I would take the outcome, right? The actual outcome, that's a 1, out of all possible outcomes, which is 6. Okay, so the probability of rolling a 1 when I roll a 6-sided dice is 1 out of 6. Okay, are we tracking with that? Okay, where it gets a little bit trickier, and let me just erase. Okay, let's say I'm rolling 2 dice now. Okay, 2 dice. 2 dice. We'll just say, you know what I mean, 2 6-sided. Okay, we need our D&Ders to come out here and correct my grammar. And then I want to know, what is the probability that I will roll a 6? Not just the number 6, but a total of 6. Okay, so now I need to see the actual outcome versus all possible outcomes, right? So the possible outcomes, that's 6 times 6. Those are all the possible outcomes. Okay, and what is that? Quick math, 6 times 6.
36.
36, good. Now, the actual outcome, getting a 6, that's the part that's a little trickier, right? So I need to figure out the combinations that would add up to a 6, okay? So I could get 1 and 5. I could get 2 and 4, 3 and 3, 4 and 2, 5 and 1. Right? If I'm rolling 2 dice, those are my options. Okay? Does that make sense? Okay. So that gives me how many actual outcomes? That would be 1, 2, 3, 4, 5. So the probability would then be 5 out of 36. Provided I didn't miss one somehow, but I don't think I did. Okay. In research, we use that exact thinking, except we make it way more complicated and it's not something you calculate easily. But really our question is, what is the chance or what is the probability that the results we got are due to complete chance and error, right? What are the odds of that? And that is what we call the p-value. So when you guys see that in research articles, when it says, oh, the results of the study showed blah, 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 with the p-value less than 0.05, right? That's usually the kind of baseline for statistical significance. Its p is less than 0.05. That is saying the probability that the results we got are due to chance or error is less than 0.05 or less than 5%. Another way to say that is we have 95% confidence in the results we got because we're assuming it has less than 5% of error. Okay, so whenever you read a research article, all of them, when they present statistics, they will always include a p-value. And the lowest level that'll be included will be 0.05. Usually for like a really strong significance, it'll be 0.01 or 0.001. So that means there's 1% error or 0.1% error. Very, very little. Which means we feel really certain, really confident that the results we got was because there is in fact a relationship between these two variables, that it's not due to randomness or chance. Okay, what questions do you guys have about that? This is kind of a meaty topic. Does this make sense? Is this something you guys have heard of before? Yes? Okay. I'm going to move it along then. So let me know if you have questions as we go through. All right. So the probability is a proportion that is from 0 to 1, or it can be a percentage 0 to 100%. That is again notated as an italicized lowercase p, and p is smaller than 0.05 as the most commonly used level or baseline or alpha that you'll see in the literature. Okay, so if you think about the normal distribution as a probability distribution, think of it as percentages that sum to 100% or a proportion of 1, which we were kind of already doing last week, right? When we had our normal curve right here, right? And then I think we were doing like the written part of the SAT, I forget exactly what it was, but it was like 475. And then a student, you know, got over here at 605. Okay. And then we were able to say that this student was at, I forget the exact number, but let's say it was like 92nd percentile, right? So think of the normal distribution again as a sum to 100. So this score showed that that student was at the 92nd percentile, or that their score was above 92% of the population, okay? Or that there's only 8% of the population that was better than the student, or that the student was in the top 8% of the sample or the distribution. Okay. This is relative frequency methods to help us predict behavior. Okay, so this is the percentage of US adults who use each social media platform. So you have Facebook, Instagram, LinkedIn, and Twitter. And gosh, it's crazy because I feel like this is dated already. This is just from 3 years ago. But I feel like we need to add, what are other popular social media platforms? I feel like we need to add TikTok. Does everyone TikTok, or is that just?
Yes.
Yes. No, Aaron is like, no. Guys, I'm going to be totally honest. I don't get it. Aside from my kids trying to teach me like some sort of renegade dance, which they filmed and thought was hilarious because I'm terrible at it. What is the purpose of TikTok? I'm asking honestly now. What is it?
I mean, sometimes there's funny videos on there.
But like, is it made to be like an accidental video, like A of V, like, oh, somebody fell, or it's intentional, like a skit?
Do you know what a Vine is?
Okay, I love this. You're like, we need to go back old school. Liz is
Do
like,
you know what a
Professor
Vine
Old.
is though?
Like those 8-second or 6-second videos?
Yeah, it's like kind of like evolved from that. So like, yeah, it is on purpose. Like,
Okay.
I don't know.
So it's not meant to capture like A of V kind of moment, like, oh, I can't believe that guy fell. It's meant to be like an intentional video.
I mean, like some do. Some are like caught on accident or like fails, but like, yeah, kind of.
Then what is the
It's
purpose of it for
whatever-
like, oh, sorry, go ahead. I feel like I interrupted.
I was just saying, like, everyone's like TikTok, like for me, like what comes on my explore page or like my like For You page, like is different. So like it like caters to like your own personal interests, if that makes sense. Like I don't know what the technology is or algorithm, but like yeah, they use like this algorithm to like kind of send certain videos to certain people. So like for me, for example, like if like Liz or Grace likes like, you know, if they like makeup videos or like whatever, they'll get makeup videos, but I like funny videos, like for example, like AFV type things, like people falling and like
Yeah.
crashing into things. That type of video I get. So it just, yeah, it just depends.
Okay, so there is a part of it that is catered to you. So there's an algorithm there. But I guess I'm struggling to see how it like, how does that help your business? Because I feel like I've been hearing so much about that. Like, oh, you need to be on TikTok. Much like, obviously, Facebook and Instagram, I've caught on to that. Obviously, LinkedIn, I'm still not getting how Twitter helps businesses. Maybe I need to do more thinking on that. But when people say
It's good
TikTok, I'm like,
advertising.
what? It's advertising?
Yeah, because you can access so many like different people and like a different demographic.
Okay.
Through TikTok, like if you're a business and you make like a funny video, then more people are gonna be like want to like buy things from you more. It's kind of like Wendy's like is really like funny on Twitter and stuff, and they'll like kind of like take jabs at other like franchises.
Ah.
So it makes them more the company more appealing.
You guys need to teach me one of these nights. We'll just reverse class and just pour into me all the things about technology and social media that I know nothing about, because it is painful how little I know about that. So I would add, so obviously this textbook is also dated. So maybe TikTok needs to be a column here, and like Snapchat. People watch videos on Snapchat, right? It's not just like secretive pictures you don't want other people to see. That's what I thought it was only. I was like, my brother and I was like, oh, I'm on Snapchat. I'm like, oh, what are you doing? What are you doing to my sister? He's like, it's nothing like that. It's for work. I'm like, really? Really? Anyway, okay, I feel like we've digressed here. Relative frequency. Sorry, gang. I took a major right turn. So you can see here the breakdown in racial and ethnic background, age, and gender disparity, right? So you're looking here at different percentages, which helps you predict if you knew that you were dealing, a man in terms of what's their social media use. Based on this, with a fair amount of certainty, you could say they're more likely to use Facebook than they are to use Twitter. So this is why relative frequencies can help us. That's where I was going with that. And then okay. Again, this is the same exact thing, just showing different types. This is a bit more recent. This is for US teens. They say they use these social media, and this is what they say they use the most often. So even though they utilize all of these at these rates, then you could see what they're using more often. So again, relative frequencies can help us in creating probability. So again, if you're meeting a random teenager, you are probably going to suspect with some level of certainty that their Reddit use is pretty minor, but that instead their use of Snapchat and YouTube is a lot higher, right? So by using relative frequency with a certain sample, you can generalize it to the population and create probabilities. Okay, this is another example with the same thing. So you're using the relative frequency method. Make sure I got my laser on. This is a sample of 200 teen girls. The question was, how many text messages do you send in one day? You could see that the average here, this mu, was 70 with a standard deviation of 10. So what is the likelihood that a random sample of teen girls will text 70 to 80 times per day? Okay. So this is important. We've worked on this before, but this is something you need to know for the exam. If I know that this is here 70, and I know that my standard deviation is 10, then over here, that's 80. Over here is 60, right? Now, this is a normal distribution. That is a given. And this is the spread that we know is true for a normal distribution. So now my question is, what is the likelihood that a random sample will fall right into this band? What do we think?
Would you divide
34.
the 68.26 by 2?
Okay, so two of you were talking, so I didn't quite hear. What's that?
Would you divide the 68.26 by 2 to get that number?
Yep. So, or, I mean, it's just written right here, 34.13. Is that what you're going to say too, Diana? Yeah. Okay. So the same way, if I said, what are the odds, or what's the chance, or what's the likelihood that a random sample of teen girls texted between 90 to 100 texts per day, I would just go to this band. Okay. Now, trick question coming up. Not really tricky, but okay. What is the likelihood that a random sample of teen girls text more than 80 times per day?
Would it be 15.73?
Yes, very good. So then you need to add these two areas. Okay, or you could add all of these right here and do 100 minus, right? It's a reciprocal curve. Okay, So just be mindful. There's going to be questions like that that you look at. You need to be able to manipulate the normal distribution and where the percentages fall. Okay, so what is random sampling? It's a sample that is designed in such a way to ensure two things. One, that every member in the population has an equal chance of being chosen. And that two, each combination of the sample numbers has an equal chance of being chosen. Okay. We use random sampling in social sciences fairly often, but most often we end up using what's called convenience sampling, which is non-probability sampling. Convenience sampling is saying, hey, I want to do a study and I want to know about people's views of, I'm going to make something up. Whether Grand Rapids should get a professional sports team come over, whatever sport. So I'm going to go to 3 different Starbucks in Grand Rapids and interview people, the same 5 questions, and then see what they answer, right? So, and then that's going to tell me how people feel, how people who live in Grand Rapids or Grand Rapidians, however you say that, how they would feel about having a professional sports team in the city. That is considered a sample of convenience because I parked myself at Starbucks and whoever came through, I asked them to participate. That is very different than doing a random sample, which would be finding out all of the people that live in Grand Rapids, have a super long spreadsheet with the thousands of people who live here, and then say, hey, I want 100 people, so I'm going to enter it into a random number generator for 100 people, and then all the case numbers that give me, I am then going to reach out to those people to figure out how they feel about a sports team in Grand Rapids. That is probability sampling. That is random sampling because every member of the population had an equal chance of getting selected and every combination in the sample had an equal chance of being chosen, okay? And that is not convenient. That would take a long time, right? Okay, so that is very different. So in psychology, most often we use convenience sampling because that is far more readily available. It's cost effective, it's efficient, it's all of those things. But then if we have a research design that has multiple groups, we'll utilize what's called random assignment. So if I'm trying to figure out, okay, so if for this class, after 2 years, I've realized, wow, my students are really struggling. I want to see if they could benefit from additional services. And I'm wondering what is most beneficial. Is it having a one-on-one tutor or is it having small groups? So then I could have all of my students for all my sections be randomly assigned to one of those 2 groups and see if there's a difference in how they perform. That is random assignment, which is different than random sampling. Are you guys hearing the difference between the 2? Okay. So simple random sampling, I just finished talking about it, but it's a sample design in such a way that every member has an equal chance of being selected and every cluster or combination of members has an equal chance of being selected. So I can give each student a number from 1 to 2001. Let's say there's 2001 students, and I can randomly select a number without replacing it, right? Because I don't want the person to be selected twice. So I select 1, do it again, do it again, do it again for 30 times, and that gives me a random sample of 30. By the way, that would be very inefficient to do. A much better way would be to use a random number generator and having a spreadsheet, but you get the idea. Okay, so that is simple random sampling. Every single person within the population had an equal chance of being selected, and I just randomly pulled the 30 that I need for my sample. Okay, a systematic random sampling is a little bit different. So that is selecting people in your population, but every kth number, which is a weird thing to say, but that's determining, hey, every 30 or so, I'm going to select a person. Now, in real life, where do we see that happening? This systematic random sampling. Where have you guys seen that before? What do we think? Do you ever see that, let's say, near the 4th of July, the police, maybe they decide that there's a lot of partying going on, they're concerned about DUIs, and they set up a sobriety checkpoint, right? They would use a systematic random sampling that maybe every 5 cars, they stop them and give a breathalyzer test. Or if you think of at the airport, the TSA, maybe every 10 people, I'm not sure what the number is, but they'll swipe their hands for that gunpowder residue, right? So that's another way to have a systematic random sampling. So they have decided every 10 passenger that goes by, I check their hands. Or every 3 cars, I check to do a sobriety check. Okay? That does 2 things. That gives you a random sample, right? Because you're not saying every red car or every person who is traveling without luggage somehow looks, oh, thanks, Grace. So there is some randomness with that. Now, in reality, is the person who's doing it will also use their best judgment, right? If there's a car that's swerving through and the person can barely make a sentence, they're like, well, this is the 2nd car and I do every 3rd car, so I guess I'm not going to check it, right? No, obviously that's happening. But when you're sampling for research, you're not actually interviewing or interacting with anyone. So doing this takes away any potential bias, right? You're systematically selecting every X number within your sample, okay? So K would be your entire population size divided by the sample size that you want. So if I know the population size of Aquinas is 2001 and I want a sample of 30, that tells me that every 67th student needs to be included. So then I could get a list from the registrar of all enrolled students, and every 67th entry, I would request for that student to participate. Okay, until I hit 30. Does this make sense? Hopefully, yes. This is what it looks like visually. Here we go. So again, if I'm looking to get a population of 40, there's 40 students and I want a group of 8 students, I would select, excuse me, sorry, I would select then, is it every 4 or every 5? Every 5, so I don't know why 4 is selected here. Oh, they just start, oh, yeah, that's fine. So, but there's a spacing of 5 between all, 9 to 14, 14 to 19, 19 to 24, and so on and so forth. So you're spacing it, so every 5 you're selecting. Okay, so that's systematic random sampling. Stratified random sampling is a little bit different. So it's dividing the population into subgroups on one or more variables that are central to our analysis. Okay? From that point on, you then draw a random sample from each of those subgroups. So for instance, if you divided all Aquinas students by major, right? Psychology, history, biology, math, divinity, whatever, you would then take a sample from each subgroup. The other way you could think about that is think about all Michiganders and you divide them by race and then you sample within each of those racial groups. That is stratified random sampling. So first you figure out groups of interest, then you sample from within. Okay? Yeah.
So could you give an example of this? Would it be like you just take a group of people based on a certain amount of variables or whatever, and then put them into subgroups because of that, and then you take randomly from the subgroups?
Yeah, so maybe I think this next slide might help you a little bit, Camilla. You tell me if I need to clarify a little bit more. But it would be looking at if I'm trying to sample, you know, if I want to sample a group of folks in Michigan and I want it to look like the distribution of the population of Michigan based on racial groups, then I would want to make sure that each subgroup is represented. In other words, if I know that the population of Michigan is 79% Caucasian, if I just randomly sample 100 people, there's a good chance that more than 79 will be white, right? Just by randomness of all of Michigan, if I'm just in Grand Rapids. So then I can purposefully say, I want to make sure that each racial group is represented. So then I could seek out and try to solicit through my sampling groups, you know, random participants from each group. Does that make a little bit more sense? This way I have a more equal sample. Okay. So then this becomes my goal. If, you know, I've got 100 that I'm trying to sample for my group, then I'm trying to aim for it to mimic the actual racial grouping of Michigan within my sample. This would be a proportionate stratified sample, meaning the proportions within the groups mirror the proportions in the population. Okay. I could do it this way, or I could do a disproportionate stratified sample, which is saying that it's going to be disproportionate for what it is in the population. So for instance, in my example of Michigan, instead of making it 79% Caucasian, and I forget all the percentages here, 14% African American, let's say I'm just interested in race relation between those two groups, I might make it 50 and 50. Well, that's obviously disproportionate because my general population in Michigan would have a racial representation for African American at 14%. So I'm oversampling in this group and undersampling in the Caucasian group to make them equal. Okay. So in order to have a 50, so yeah, exactly what I just described. So it's just disproportionate to the population. Now there's times where I want to do that, right? If I'm looking at Michigan's views or Grand Rapids views on the police force, and the results I keep getting, people don't think it's an issue, but it's based on 79% white respondents. Now, all of a sudden, if I make it 50-50, it may highlight that a racial group feels differently than another. So that's a time where you would want disproportionate sampling. So you give really an equal voice to all groups. Does that make sense? Hopefully. Okay. All right, so here's a little drawing to show exactly that. So this would be a disproportionate stratified sample. So if I know in the population, here's the breakdown of groups for women over the age of 50, you could see that there's over double white women that are over the age of 50. But if I do a disproportionate stratified sample, see, I'm trying to make my groups all equal, despite the fact that in the population, that's not how they're represented. Okay. Now let's talk about sampling distribution. So a sampling distribution is a theoretical distribution of all possible sample values for the statistics in which we're interested in. Okay. A sampling error, on the other hand, is the discrepancy between the sample estimate of a population parameter and the real population parameter. So that's your sampling error. Let's give it an example. I think that'll help. Okay, so this is the population of personal income for 20 individuals. So there's 20 people in our sample. This is their income. Okay, it ranges from 7,000. I think that's the lowest number, 7,000 to 68,000 with a mean of 22,000, standard deviation of 14,000, okay? Now let's say I take a sample. I'm taking 3 random from that group, okay? Well, I could take these 3, and these 3, And now I need to look at their mean, okay? So I calculate a mean for their 3 incomes. That gives me 20,817. The mean for these 3 incomes gives me a mean of 21,345, okay? I would need to repeat this process 48 more times so we have 50 samples of a size of 3. That's how I would do a sampling distribution, okay? Now maybe you're going, why in the world would I do that? So let's go a little further. So you can see here, the first set of 3, here's my mean, second set of 3 is that all the way down to the 50th. So I have 50 samples, and then the total for the 50 samples you see is over $1 million. And the mean of my samples is 24,749. So by doing that, this is a sampling distribution of the mean. It's the theoretical probability distribution of samples that would be obtained by drawing from the population all possible samples of the same size. So this is to give me a probability. This is to give me like, what are the odds that I would get this? So it's coming up with every single iteration. I want to be clear, you guys are not going to have to compute this. This is kind of theoretical talk now. It'll make more sense in a minute. Okay. This is the distribution of grade levels among 90,000 school children. This is not real again, as they're not actually doing that. You see the number of students is 10,000. There's 90,000 total. It's all evenly distributed between all grades. They each have 10,000. Okay. Oh gosh, that got all messy. The distribution of the means of the 3 randomly taken samples of 2 school children's grade levels, each from a population grade levels of 90,000, you could see there is my mean, okay? So it's again, combining different groups, and here's how it's laid out. And then here it shows it again. So I can see all of the different means for the population mean, and then I grab different samples. The more I sample each result, the closer I get to my population, because I have an increased number that is in there. So more sampling brings you closer to that population mean, right? You're reducing the amount of error. You are approximating the population closer and closer. Okay. Visually, here's what it would look like, okay? You can see this is for n of 50, and then we get to n of 1,000. You see here at 50, it's quite flat. This is, again, the distribution of the sample means. So this is, I'm taking multiple samples of 3 again, or 5, whatever it is, within my actual sample, and then I keep comparing them to one another. But the greater the number, you see, the greater it approximates a normal curve. Okay, so again, the take-home message is this. Theoretically, distributions of means are based on a very large number of samples of the same size. And each sample is randomly drawn from the same population of individuals. That is what a distribution of means is. You're constantly sampling and resampling the same number, right? 3, 3, 3, 3, 3, same number of samples, I should say, and then comparing the mean within them. And some of the characteristics you see is that the shape, the greater sample means you have, the more it approximates a normal curve or a normal distribution, okay? Again, there's some like characteristics that need to be present. One of them is each sample includes 50 or more individuals, and the distribution of the population of individuals is also normal. Okay. This is the last thing I'm going to say about that. This is the rules for determining the distribution of means. Again, we just need to go over this. There's not going to be a lot at all on the exam about this. So the mean is the same as the mean of a population of individuals. This is why it's powerful, right? Because the sample could be biased. There could be error in how we sampled, so it could be quite different, right? I like to use this super random example. And in fact, now I feel like I need to show you this. Can you guys still see my screen? Hold on, let me pull it up real fast. This will be worth it. I mean, I think it's worth it. Now you may think I'm crazy, but you probably think that already. So, okay. Funsies. If I asked you guys, which of these Chris's do you get rid of? Okay, we've got Chris Hemsworth, Chris Evans. I always get this wrong. I think this is Chris Evans, Chris Pine, and Chris Pratt. And this is not a good photo of Chris Pratt, but we're just going to go with it. Which one do you get rid of? This is all I'm telling you. Which one do you get rid of? Nothing else. So, little statistic here. Who do you get rid of? Who votes for? So we'll have Hemsworth. Can you guys still see my notation? Am I doodling? Okay. Evans, Pine, and Pine and Pratt. Enter in the chat. Who do you get rid of? Or you can just say it out loud, whatever. Okay, 1 vote for Hemsworth. This is fascinating. I've done this in 3 classes today. So I am doing a sample mean. Okay, I need to scroll back up. So first one was Hemsworth. Okay, I need to look at your face. Who's this? Liz. Liz, your face is not up there. You voted out Chris Hemsworth.
Yeah, it was hard, but the other 3 I like better. So
I'm sorry to say you failed this class. I will see you in the fall.
all right. Yeah.
Chris Hemsworth is my favorite of all. My son, when he was 5, this several years ago, there was like a flyer that came in the mail, and it was for like, I think he was doing ads for watches. He was like, Mom, here's the man you love. And I was like, shh, thank you. I will keep that. Okay, you gotta love Thor. All right, so Hemsworth. Annette, which P do you mean? Because there's Pratt or Pine.
I meant Pine. Sorry, I put it in there twice.
Pine. Okay, so Pine. Let's keep going down. PR, Pratt. Oh, we've got 3 Pines. Oh, it's a bad day. Okay. Oh, Annette, I counted yours twice. Okay. Stephanie, Mallory. Camilla's like, I'm gonna be different. I'm gonna say Evans. I like it. Pine and Hemsworth. Hannah. Can't believe you.
I agree with Liz. I like the other ones better.
I'm sorry, you broke up. I can't hear you.
Oh, I agree with Liz. I like the
No, I was
other ones better.
joking. I heard you. Okay, so from this sampling, first off, how much direction did I give you guys? Who are we kicking out? What is it based on? What are some of your, like, how did you select here? I'm curious now.
I think Chris Evans is one of the most beautiful men on earth. So
Chris Evans?
Oh wait, I didn't mean to put Pine. I'm kind of going by looks here.
Yeah.
Who's the last one?
Pratt.
Okay, put me down for Pratt instead of Pine.
Okay. So I love this. We have really, this is for the sake of statistics. Okay, Hasher, I want to go back to what you said. So did you select Evans? Or you're saying Evans is the most beautiful, so you wouldn't kick him out? Yes, that. Who did you kick out?
Pine.
Pine. I get them mixed up. Okay, so this is Evans and this is Pine. They
Yes.
look so
Evans is the second
similar
one.
to me. Okay, so Hasher, it sounds like you went by looks, right? Like you're like, get rid of Pine. He's
Well,
not
also
attractive. Captain America.
I think
Okay. Yeah. Okay, what are some other reasons why you guys kicked out whoever you kicked out?
I went by what characters I like best in shows and movies.
Okay, so
So,
like
like,
based on actors.
Parks and Rec, that's like my favorite, so I can't kick out Chris Pratt.
No, I can't get out Chris Pratt. Again, this is a terrible photo, but yes, he's such a good character in that. Okay. What was his character? What did he play? Like a pretend detective or PI? He had like a fun name.
Yeah, it's so funny.
What was that name? I can't believe I've forgotten that now. Anyway. Okay, others of you.
Chris Pratt, okay, I do have to say something good about him. He was in such a good movie. I know he was in Guardians of the Galaxy and Jurassic World, but he was also in Passengers, and that was such a good movie.
Oh, don't know that one. Okay. So it sounds like maybe going off of talent and the roles they've played. Any other reasons why you kicked them out?
I started off looks, and so then it was going to be Pratt that was out, but then I was like, no, he's funny. So that outweighs that he's not as cute. So then I went for Evans.
Okay.
Yeah.
Because you don't like Chris Evans. You're like, meh. Okay. Just don't tell Hasher. You guys are right next to each other on my little queue, so that's kind of funny. Okay, so again, in this particular very significant statistics we just ran, I didn't give you very much parameter. If I said which one of these is the best actor, or which one is the worst actor, or which one is the best looking or worst looking, right? So you utilize your own kind of filter to look through it. Now, if I then said, so how many do we have total in our sample? I need to vote, and my vote is Pine also. That's who I would kick out. So 6, 10 out of 13. If I said 6 out of 13, that's like almost 50% of Aquinas students hate Chris Pine. Would that be an actual representative sample? Like, is the sampling, in other words, that I'm doing in this class, does it represent all of Aquinas students? No. Why is that?
I would say, like you said, it's depending on the basis that you are like questioning that, like, you know what I mean, like what you're voting them out on. So like specifying what you're voting for would skew like the results in terms of what people would vote for. And sorry, I keep getting a internet is unstable thing. I don't know if you guys can hear me well or not.
You break up a little bit, but I think I heard the bulk of what you were saying. Yeah. So it's not a great sample because it wasn't a clear question. Is our sample size also represent, if I think about stratified random sampling, does the composition of this class match all of Aquinas' campus?
I think given the fact that our class is mostly like, you know, girls, they'd be more inclined to be attracted to them. I don't know. I don't want to like assume anyone's like sexuality or anything, but like, yeah, you know what I mean? So like,
totally.
I think if you were to throw more guys in the mix that aren't as physically attracted to, you know, like whoever, I think, and they base their minds, like their opinions on different aspects of the actors, then I think that would also have an effect on like the end results.
100%. 100%. And again, this is a class that is mostly female. There's, you know, just a couple of you guys representing the male, you know, contingency. Who knows, right? Like there might be guys who go, well, no, I would actually pick Chris Evans to kick out because, you know, in, you know, issue number 3 of Captain America, when I was reading the comic books as a kid, he acted this way. And in the movie, he didn't do it right. Like, again, there'd be more nuance to what we were seeing rather than mostly looks, which is what most people do. And again, it's okay, Stephanie, spot on. Too generic of a question. The sample size is far too small. Mallory, you're right on. Again, this is not representative. And interestingly, Chris Pine's having a bad day, gang, because he was top picked to be kicked out in all classes I used this little quiz with. So it's a bad day to be Chris Pines. I don't know what to make of that. We'll just leave it be for now. But going back to lecture, here it is. And where is the rest of my lecture though? That's not good. Here's that. Again, if I was doing a sample mean, through my sample mean, again, Chris Pine is popping up as the highest picked. So I could say that generalizes closer to the population of Aquinas as a whole. So even though each sample was very small, when I do a sample mean of my sample distribution, I'm getting closer and closer to the general population, which for us is Aquinas students. Okay, the shape of the distribution is going to be approximately normal for sample sizes of 30 or greater. And again, it's going to be for sample size that are 50 or greater, it's going to very much approximate a normal distribution. even if the population itself is not normally distributed. So again, this is the sample mean will approximate a normal distribution the closer we get. So here's what it looks like. This is the distribution of the population individuals. The distribution of the means is far narrower because you're just comparing mean to mean to mean to mean. So the variation, the variance is going to be much less, right? Less variance right here. So that's why it's a thinner curve than here. Okay. Just as a brief reminder, there's different kinds of distribution that you can see. But all of these are all normally distributed. It's just the variance changes. Okay. You have less variance here. This is just a small sample size, smaller size than these two. So that's why it's a bit more jagged with hills and all that. Okay. When you are doing a sampling distribution, you want to know about standard error of the mean, right? It's all about understanding how much error is present in what I'm calculating, because that's going to make an impact on how much I trust the results. Okay. So the standard deviation of the sampling distribution of the mean is the standard error of the mean. It describes how much dispersion there is in a sampling distribution of the mean, and it tells us how much our sample is in error of the actual population mean. How much do we differ? So the simple example I give with that is if you are, and again, I'm going to speak outside the realm of my expertise, but when you golf, right, you can be given a handicap, right? That's a score to buffer your score, to bring you closer to an average golfer score. Okay, is there a golfer in here that could make sure that I describe that well? Use of handicap. No golfers in our class? Okay. Does my example kind of make sense? Do you know what I mean though with golf? How people have a handicap to bring them closer. Okay, we're just gonna stick with statistics. Liz, thank you. I needed that thumbs up. So the way you would calculate it is you would sum all of the means from your sample distribution means and divide it by your actual mean, right? And then you get this number right here. That's your sample distribution mean. Sorry, not mean, the number of times. That's like your N, how many samples you grouped. So that's like doing a normal average or mean, so to speak, but you're just averaging the means. Standard deviation is going to be exactly the same. You're going to calculate your variance divided by the square root of your sample, which in each sample there's 3, going back to our other example. So this is what you would get. Takeaway big picture item that you need to recognize. When we have a sample, our goal is to have it approximate the population. That's our goal, right? We don't want to include everyone in the population, too time consuming, too expensive. So we create a subset, a sample. We try to have that sample be non-biased. The way we do that is through probability sampling. So we randomly select people through like a random number generator, or we do the systematic probability sampling, right? Where we say every 10th car, I'm going to pull over and ask them about their driver's license, making stuff up here. So by doing that in my sampling, I am reducing bias and I am approximating the population more accurately. If I want to totally geek out and make sure that I've done it correctly, I can do a sample distribution mean, which is looking at my sample, and then I grab, let's say, 3 of the scores in my sample, and I come up with all the possible alternative combinations of 3, calculate their mean, and then I add up all of their mean divided by the total number of iteration. That's what this is right here. And this number is going to be the closest to my population mean. Again, my goal is for my sample to be as closely resembling to my population. So by doing a sample distribution mean, I get even closer to it. Now, true moment here. How often do people do that? Hardly ever. If you've done a good job sampling individuals to be in your study and they in fact approximate your population, just doing a straight up mean should be good enough. Okay. This is in your chapter, so I need to cover it so you guys know about it. But it doesn't get used all that often. Questions about that? Hopefully my quick summary helped a little bit. Okay. All right. Central limit theorem. Big asterisks, you need to know about this. Okay. So if all possible random samples of size n, whatever your size is, are drawn from a population with a given mean and a given standard deviation, then as your sample size becomes larger, the sampling distribution of sample mean becomes approximately normal. Okay. What does that mean? Excuse me. If you're taking all, again, sampling mean right here, your sampling distribution of the means, the more of them you take, the closer it'll approximate your actual population. With a sufficient sample size, the sampling distribution of the mean will be normal regardless of the shape of the population distribution. I said this a couple slides back. Okay, so these are the big take home. As the sample size gets larger, the mean of the sampling distribution becomes equal to the population mean. What is key about this is as your sample gets larger, the closer you approximate your population mean, okay? Similarly, as the sample size gets larger, the standard error of the mean or the standard deviation of all the sampling distribution decreases in size. Okay, so two things happen that are key to note. Central limit theorem tells us the larger your sample size, the closer you are approximating your population mean. And the larger your sample size, the smaller your standard error of the mean becomes. In other words, the less likely it is that you've gotten this answer by chance, right? Or that there's error in your response. Okay. Okay, did that make sense just before I move on? These are the two takeaways, asterisks, highlight, I don't know, shoop, shoop, make sure you look at that. Okay. This is an example. This is the population distribution of personal income for 20 individuals. Okay. So this is where their income falls. It's the percentage of individuals that fall into those groups. Okay. You can see it has a mean of 22,766, standard deviation of 14,000. Okay. This is the sampling distribution of the sample mean for sample sizes of 3 for that same population of 20. So they took 3 of those scores, 3 of those incomes, combined them, did means, right? Okay, and this is what they got. So the mean of the mean was 24,750 with a standard deviation of 8,480. Okay. We're going again. This is a sampling distribution of sample means for sample size 6. So instead of grouping them by 3, they group them by 6. Okay. And now we get a standard, a mean of 24,064, standard deviation of 5,995. So our variance, our standard deviation keeps decreasing. Do you guys notice that? Okay. Let's go back. Start at 14,000. The mean at 22. Now we went to 24 and 8,000. Now we're at 24 and 5,000. Okay. So we are reducing the amount of variance because we are sampling the means within themselves. So there's less and less difference. There's reduced chance. Okay. This is the last take home because this is going to be important. If you have a sample, this is how you notate the mean, or as I've highlighted, it could also be an X with a bar on it. Both of those are fine. Standard deviation is a lowercase s. Population distribution, you've got the mu here and a sigma for standard deviation. And then honestly, you could kind of ignore this. I am never going to ask you about that, but for your own edification, this is how you would notate the sampling distribution of the mean. Okay. From tonight's lecture, which was meaty, we didn't take a break, you guys rocked it. Here's what I need you guys to remember. especially as we consider the exam coming up next week. You need to know, what is the central limit theorem? What does it state, right? Take home points. The greater your sample, the more it approximates your population mean. The greater your sample, the less error you will have in your statistics. And I said statistics because that is what we call it for a sample. If it is a population, we call it a parameter. Okay. You need to know the different types of sampling. There's probability sampling, which includes this proportionate stratified sampling. It includes simple random sample, systematic, and stratified. Okay. All of those are probability sampling. There's other types of sampling, which includes sampling of convenience. It's not a huge part of your chapter, but you should be aware of what it is. You should obviously also know, what is a population versus a sample. Okay. Questions about class? Does this make sense, what I talked about today? Everybody on the same page? We feeling ready for the exam?
Is the exam timed?
No. So I will have it go live probably closer to 10, and you need to make sure you've submitted it back to me by midnight that night.
Okay, thank you.
No problem. I shared at the start of class that most students completed an hour, maybe an hour and a half. What I have discovered, this is the third semester I teach more like online, is it takes people a lot longer online than it does in person, because you guys have everything available to you, and oftentimes you second guess yourself, then you start researching, and now you go down this rabbit hole. It just ends up taking longer. You don't have to do that. Trust your gut. You guys got it. Any other questions?
Oh, sorry.
No,
I
go
had a
ahead.
question about the syllabus. It looked like next week we had a lab due, or
Yes.
we'll have a lab due.
No, and I don't know why I was like super grumpy when I made this. That was mean. Here, let me share, because gang, Diana's totally right. This is next week, and yeah, a lab due on the same day. That's rude. I did not mean to do that. You don't need to do that at all. We will talk about the lab next time we're all together, which will be week 9.
Okay. I just wanted to make sure I wasn't missing anything.
No, you're not. And I'm glad that you brought it to our attention, because some of you might have been freaking out like, what in the what? She didn't even talk about the lab. No, we'll do, it's fine. We'll do a slightly different lab than I had expected to do. But there's no sense in having a lab due the same day that you guys are taking an exam. Again, that was rude of me. Good clarification. Any other questions I could be helpful with?
Will the Chris's be on the exam? Just
Oh
kidding.
my gosh, I should totally do a bonus point. If you've been in class, you know how Dr. Woltel feels about one of the Chris's. Which
Well,
one?
I'm gonna fail because that's not fair. Like I'm better, so I'm
No, I didn't say how you feel about it, just how do I feel about it. That's clearly all that matters. I feel like I need to get some professor kudos amongst my peers if we were more cohesive, but with COVID we're not, that I was able to include them in 4 of my classes this semester. I just weave that into all topics. Yep. All right, anything else? Otherwise, you guys have a fantastic week. Enjoy the fabulous weather we're set to have for the rest of the weekend. I think I saw like 60-degree weather. That'd be awesome. And enjoy the exam as much as one can enjoy an exam. Reach out to me if you have any questions. And then I will see you again, week 9, which is Wednesday the 17th for St. Patrick's Day. Okay. All right, you guys have a great rest of your night.
Thank you.
Have a good night.
Thank you, Doc. You too.
Bye.
Bye.